We've talked about CAPM and its applications, but what we need to recognize is that CAPM has several limitations. The limitations can broadly be categorized as theoretical and practical. Under theoretical limitations, the first issue is that CAPM is a single factor model. So the expected return is equal to the risk free rate plus beta times the market risk premium. So here, the only factor which is related to the asset is the beta. So essentially, what this model is saying is that the expected return is derived or estimated based only on a single factor or a single characteristic. So according to CAPM, factors other than beta don't matter. So that's clearly an issue because there will be other factors that drive returns. Then we have the fact that CAPM is a single period model. The issue here is that if we have factors that change over time, so if the value of the factor changes from period to period, then that's a problem. Take beta, for example. We assume in CAPM that the beta is fixed, but what if the beta of a stock varies over time and across different periods? Then again, CAPM does not work very well. Moving now to practical limitations, CAPM assumes a market portfolio which includes all assets, and these assets are financial and non financial. But practically speaking, when we consider non financial assets such as human capital, then clearly these non financial assets are not investable. So the theoretical market portfolio which CAPM assumes is not really a practical investable portfolio. The next point has to do with a proxy for market portfolio. Since the true market portfolio is not investable, market participants are going to take different proxies for the market portfolio. So for example, in the US, some participants will use the S&P 500 as a proxy for the market. But here, different analysts or different market participants might use different proxies, and that will mean that the expected return will be different depending on which market proxy is being used. Then we have issues related to estimation of beta risk. And here there are two central points. One point is that CAPM is a forward looking model. So we can say that this is an ex ante model in the sense that we are predicting or coming up with an expected return. But CAPM is based on beta, and often beta is calculated based on historical returns. So that's an issue. Beta is an ex post variable, whereas what we are coming up with is ex ante. The other issue has to do with how beta is calculated. Now, different analysts might use different time periods. Some analysts might use returns that are daily, others might use weekly returns, others might use monthly returns. So, depending on how an analyst calculates beta, they will come up with different numbers, and that will mean that the expected return will also be different. The next point is that CAPM is a poor predictor of returns. If we go back in time and compare the result of CAPM with what the actual return was, there will be a substantial difference. So CAPM is not a great predictor of returns. And the final limitation has to do with the fact that according to CAPM, there is a homogeneity in investor expectations. So investors need to have the same expectations, and investors need to come up with the same optimal risky portfolio. But the reality is that investors can arrive at different optimal risky portfolios. Given the issues and limitations associated with CAPM, it's not surprising that other models have been proposed. And here again, we have theoretical models and practical models. Under theoretical models, the best example is arbitrage pricing theory. Under arbitrage pricing theory, the expected return is based on different risk premiums. So lambda 1 is the risk premium associated with factor 1, lambda k is the risk premium associated with factor k, and so on. And then the betas represent the sensitivity of a portfolio to a given factor. Arbitrage pricing theory is somewhat similar to CAPM in the sense that there is a linear relationship between risk and expected return. But there are several differences between arbitrage pricing theory and CAPM. One difference is that arbitrage pricing theory assumes multiple factors. So, unlike CAPM, which is a single factor model, with arbitrage pricing theory, we have multiple factors. The second point is that the factors can vary from asset to asset. So, we have the risk-free rate, which is common for all assets, but other than that, a given asset can have a particular set of factors that it is sensitive to, and another asset can have other factors that it is sensitive to. So the second point has to do with different factors for different assets. And the third point is that a no arbitrage condition is used to determine the risk factors and the sensitivities. So the third point has to do with the no arbitrage condition, which is where this name comes from. While the arbitrage pricing theory is theoretically appealing, but from a practical standpoint, it has issues. One issue is that it is difficult to identify the relevant factors. It's difficult to explain these factors, and it is also hard to come up with the sensitivities of these factors. For this reason, the arbitrage pricing theory is not commonly used in practice. We therefore move to some practical models which use factors that are more easy to explain. A commonly used and popular model is the Fema-French model. So the Fema-French model builds on CAPM. Notice here that the expected return is based on the market risk premium. So we have the market factor, which is similar to what we have with CAPM, but then there are other factors also. So we have a factor related to the size of the company. Then we have a factor related to the book value to market value ratio. So with Fema-French, we have three different factors. Then there is an extension of Fema-French where we have the same three factors, and we also consider a momentum factor. Now, these models are superior to CAPM in the sense that we don't just rely on one factor. At this stage, it is enough for you to know that these multi-factor models exist. We will be studying these models in more detail at level 2. Moving now to performance appraisal measures. And before talking about specific measures, I want to give you some context. Imagine you have a lot of money and you give that money to 3 different investment managers. So you split your funds between these 3 investment managers and you ask them to manage your money. Clearly, you would be interested in how these managers perform, and to evaluate their performance, you need some measures. The sorts of measures that we will talk about here are based on capital market theory. On this particular slide, we'll talk about the Sharpe ratio and the Treynor ratio. The Sharpe ratio is given right here, and you've seen this before. It is an extremely important ratio. It's the excess return of a portfolio over the risk-free rate divided by the risk of the portfolio. We can connect this with the capital allocation line where we have the return on the y-axis and risk on the x-axis. If we have a given portfolio P, then this Sharpe ratio is actually the slope of the capital allocation line. You can notice that this would be the return of the portfolio. This is the risk-free rate. That's the change in y. The x is the risk of the portfolio. A steeper capital allocation line would be superior or more efficient because here we are getting a higher return for each unit of risk. The Sharpe ratio is simple to understand, simple to calculate, and used very often. But it has 2 limitations. One is that it uses total risk rather than systematic risk or beta. The other is that this is a ratio which is not informative in of itself. In other words, if you have a given portfolio and the ratio is 0.7, just by looking at 0.7, looking at this number, you don't know whether it is a good number or a bad number. You don't know how your manager is performing. It's only when you compare the Sharpe ratio with someone else that you realize whether it is good or bad. So if this other portfolio has a Sharpe ratio of 0.9, then we can say that this portfolio is superior to this one. To deal with this first limitation, we have another ratio called the Treynor ratio, where the numerator is the same. It's the excess return of the portfolio over the risk-free rate divided by the systematic risk. But this again is a ratio. Simply knowing that Treynor ratio is 0.9 does not tell us whether the ratio is good or not. We need to compare this with another ratio to determine which one is better. Moving now to two more performance evaluation measures, M squared and Jensen's alpha. We have M squared on the left, which is shown right here. M squared gives similar rankings to the Sharpe ratio because both M squared and Sharpe ratio use total risk. I'm going to write the M squared ratio again in order to help you memorize this ratio. To write the M squared ratio, or to help you remember the M squared ratio, let's do the following. First, simply put down the Sharpe ratio, which is return on portfolio minus the risk-free rate divided by the risk of the portfolio. Then you multiply this by the risk of the market, and then you subtract the market risk premium, which is RM minus RF. The benefit of this measure over the Sharpe ratio is that we get a number which has meaning. This is called a ratio scale, which we studied in quant. Let us say that your portfolio manager invests in a portfolio that has a return which is similar to the market, and the risk is also similar to the market. If the risk is similar to the market, then this expression will simplify because sigma m over sigma m will cancel off. If the return is similar to the market, then you have Rm minus Rf minus the same thing, which will give you 0. M squared of 0 means that the manager is not adding any value. The return and risk is the same as the market. In other words, you might as well just invest in the market. If M squared is greater than 0, say M squared is 0.5, then that is a good thing, because with M squared greater than 0, the manager is actually adding value. Let's look at how he might get M squared greater than 0. One way of doing that would be to take the same risk as the market. So sigma p is equal to sigma m. So these two terms cancel out. But Rp is greater than the return on the market. If Rp is greater than the market, then this expression will be greater than the market risk premium, which will give us a M squared that is positive, which shows that the manager is adding value. So this number has meaning. If the number is negative, that means the manager is performing worse than the market. Coming back and looking at another example where M squared can be positive. If the return on the portfolio is the same as the return on the market, but at a lower risk, in other words, sigma p is lower than sigma m, then again you will have this expression on the left being greater than the expression on the right, and you will have a positive M squared, which means that the manager is adding value. So the good thing about this measure is that the number makes sense. However, the limitation still holds because we are using total risk and not systematic risk. Theoretically, the best measure is Jensen's alpha, which is a number which has meaning, and it uses systematic risk. Jensen's alpha is simply the return on a portfolio minus the return predicted by CAPM, which is this expression over here. If you have a given portfolio where the return on the portfolio is equal to 19% and the number predicted by CAPM is 17%, then Jensen's alpha is 2%. And that indicates that the manager is adding value because at a particular level of risk, he is doing well. The Jensen's alpha will give a ranking which is similar to Treynor ratio because both Jensen's alpha and Treynor ratio use systematic risk. On this slide, I will summarize the 4 measures that we talked about and help you remember them. First, we talked about the Sharpe ratio, which is the return on the portfolio minus the risk-free rate divided by the risk of the portfolio. There are 2 issues here. The first issue is that it's a ratio, so the number in of itself doesn't make sense. The second issue is that it uses total risk and not systematic risk. To address the risk issue, we can use the Treynor ratio, which is return on portfolio minus risk-free rate divided by the systematic risk. But this again has a problem where we are coming up with a ratio which in of itself does not have meaning. It has to be compared. Then we talked about m squared, and here again I'll help you remember m squared. We first just write out the Sharpe ratio, and then we multiply this by the market risk and then subtract the market risk premium, which is Rm minus Rf. This is the m squared measure, and a number of 0 means that the manager is not adding any value over the market. A positive number means that the manager is adding value. A negative number means that the manager is destroying value. And finally, we talked about Jensen's alpha, which is the return on a portfolio minus the expected return based on CAPM. Before you do example 10, I want to highlight one more point. It makes sense to use the Sharpe ratio and the m squared measure if you are evaluating a manager where you know that the portfolio is not diversified. On the other hand, if the portfolio is supposed to be diversified, then it makes more sense to use the Treynor ratio or Jensen's alpha. We now come to the final section of this reading, which is applications of CAPM in portfolio construction. Here we will talk about the security characteristic line, security selection, and then implications of the capital asset pricing model for portfolio construction. Security characteristic line. The security characteristic line is a plot of the excess return of a security against the excess return of the market. The equation is given right here. This is the excess return of the security. This is the excess return of the market. If you think of the plot, you have excess return of the market on the x-axis, excess return of the security on the y-axis. Alpha is the intercept. Expected value would be 0. Beta is the slope of this line. I don't think this is overly testable, but nevertheless it is in the curriculum, so you need to know what I have described on this slide. Security selection. This is important. In CAPM, we assume that investors have homogeneous expectations and assign the same value to all assets. But this does not actually happen. What we can do is use the SML or security market line for security selection. If you think about the SML, it is a graphical representation of the capital asset pricing model. We have talked about this before. The risk-free rate comes right here. We have beta on the x-axis and the expected return on the Y. Let's say you identify a security with a beta equal to 1. Let's say that the market return is 16%, but this particular security that you have identified has a return of 18%. In other words, it is plotting above the SML. This security is not efficiently priced. In fact, it is underpriced. Why? Because it is giving you a return higher than 16%, higher than the rate which would be expected at this level of risk. So you should buy this security. Securities that plot over the SML are underpriced and should be bought. Securities that plot under the SML should be sold because they are overpriced. Securities that plot on the SML are efficiently priced or appropriately priced given their level of systematic risk. Constructing a portfolio. Theoretically, investors should hold a combination of the risk-free asset and the market portfolio, but it is impractical to own the market portfolio. However, it can be shown that holding as few as 30 stocks can diversify away the non-systematic risk. So the point is, you don't need to hold all 500 stocks in the S&P 500 index. Simply by holding 30 stocks, you can diversify away almost the entire non-systematic risk. If you look at this graph, we have variance on the y-axis, number of stocks on the x-axis. This point here represents the variance of the market portfolio. If you have a portfolio with just 2 stocks, then it will have a relatively high risk. This part of the risk is called non-systematic risk or diversifiable risk, and this part would be the non-diversifiable risk or the systematic risk. As we add more stocks to our portfolio, the risk will come down and it will level off at the systematic risk level. We can't get lower than this because this is the level of risk that is inherent in the system. And what we are saying over here is that with only about 30 stocks, we can reach the point where we are at market risk or systematic risk. The important point, however, is that we need to pick stocks that have a relatively low correlation with each other. If all these 30 stocks are in the same industry and generally move up and down together, then we will not have a decent level of diversification. Now I want you to do example 11 from the curriculum. That brings us to the end of this reading. Let's go over the main points. You need to understand the distinction between the capital allocation line and the capital market line. The capital market line is a special case of the capital allocation line where the portfolio, the efficient risky portfolio, is the market portfolio and where we assume homogeneous expectations. You need to understand the distinction between systematic risk and non-systematic risk. The market only compensates investors for systematic risk. The measure of systematic risk is beta, and beta is equal to the correlation between a given stock and the market times the standard deviation of the stock divided by standard deviation of the market. With return generating models, we can have single factor models and multi-factor models. At level 1, we only worry about single factor models. We talked about the market model, and then we talked about the capital asset pricing model. This is critical. The capital asset pricing model allows us to compute the expected return on a security given its level of systematic risk. So expected return is equal to the risk-free rate plus the systematic risk as given by the beta of the stock multiplied by the market risk premium. The market risk premium is the return on the market minus the risk-free rate. The security market line is a graphical representation of this CAPM formula. And finally, we talked about various applications of CAPM. The biggest application is computing the required return given the level of risk. We also use the concepts discussed in this reading to come up with several measures that can be used to evaluate portfolio managers, asset managers, and so on. We talked about constructing a portfolio and said that using diversification, or if we have a portfolio of up to 30 securities, then the non-systematic risk can be diversified away as long as the correlation between the securities is relatively low. Now I want you to go over the summary in the curriculum, review the learning objectives, and make sure you can say something sensible about every learning objective. I have asked you to do all the examples in this reading. Do the practice problems. Here again we have quite a few, and they are an excellent indication of what you might expect on the exam. Also do practice questions from other sources. That is it.